In this video, we are going to discuss all the 9 problems which were asked in GATE Mechanical this year from Engineering Mathematics. And in some question, there is some confusion. For example, there was one problem based on inverse Laplace transform. Now, the same answer can be written in different ways, right? Either you can write that answer using hyperbolic function or using product of hyperbolic and unit step function. Similarly, there was one question based on Gauss divergence theorem. So in that problem, the confusion is whether we had to evaluate that surface integral over entire surface of the cone, meaning the curved surface and the circular base of the cone, or only the curved surface of the cone, right? So in this video, we'll discuss all those variations and we'll see what would be answer in different cases. So this is our first problem. The question is, this problem is based on Gauss divergence theorem. The question is vector f is xi plus yj minus 2zk, right? Ijk are unit vectors in x, y and z directions respectively. So the question is we have to find the value of this integral vector f dot n cap ds. This will be vector quantity, right? So vector f dot n cap ds, meaning we have to find surface integral of vector f over s, right? And s is the surface of the cone shown in the figure. So s is surface of the cone and this figure was given to us. Now here in this problem, the confusion is that whether only the curved surface of the cone was asked in the problem. For example, here this will be the curved surface of the cone, right? So S is only this curved surface of the cone, or S is curved surface of the cone plus the circular base of the cone, right? So this is the problem. We have to see that what would be the correct answer. But if it was the total surface of the cone, meaning if it was, let us say that this is S1, the curved surface of the cone, and this is S2. So if the question was find the value of surface integral over the total surface of the cone, meaning the curved surface and the circular base, then it will form a closed surface. And in that case, we can use the concept of Gauss divergence theorem, right? So we all know what is Gauss divergence theorem. If we have to evaluate this integral, vector f dot n cap ds over surface over a closed surface, right? If we have to evaluate surface integral of vector, either it can be written as single integral or double integral. But the important thing is that if this is the surface integral and S is a closed surface, then you can write this thing as volume integral of divergence of f, right? You can write this expression as volume integral of divergence of f, where this V is the volume which is enclosed by this closed surface, right? So this theorem is called Gauss divergence theorem. And if you see previous year paper, you will find that in last 3 years, they have asked at least 3 to 4 problems based on Gauss divergence theorem, right? In different sets, they have asked question from this topic, Gauss divergence theorem. So here, if S is the entire surface of the cone, meaning the closed surface and the circular base of the cone, right? The curved surface and the circular base. So in that case, we can use the Gauss divergence theorem. And here, if you notice f, this is the expression for f, xi plus yj minus 2zk. So vector f is, let me write vector f here. Vector f is xi plus yj, right? It is xi plus yj minus 2zk, right? This is vector f. Now here if I calculate divergence of f, so divergence of f, this will be nothing but partial derivative of u with respect to x plus partial derivative of v with respect to y plus partial derivative of w with respect to z. Or you can write f1, f2, f3. u, v and w are nothing but x, y and z component of this vector f, right? So partial derivative of x component with respect to x, this will be 1. Partial derivative of y component with respect to y, this is 1. And partial derivative of minus 2z with respect to z, this will be 2, right? So 1 plus 1 minus 2, this will be 0. Now since divergence is 0, and we know that using Gauss divergence theorem, we can write that surface integral as divergence of f dot, divergence of f, right? Volume integral of divergence of f. So here, since divergence of f is 0, therefore you can say that this volume integral will be 0, right? And using Gauss divergence theorem, one can say that if volume integral is 0, then that will mean that the surface integral over the surface of cone, this will be 0, right? So if the question is S is total surface of the cone, right? S is the curved surface as well as the circular base. Then in that case, the answer will be 0, right? The value of this integral will be 0. Now let us see what will be the answer in second case, right? Second case meaning that here S is only this S1, right? S is only the curved surface of the cone. Now see, we have discussed one similar problem in our video course. So let us first see the discussion and then we'll come to that problem. So if I have to evaluate surface integral over S1, the closed surface, the curved surface of the cone, so you can easily see that for this curved surface, the direction will change continuously, right? This n cap is the unit vector which is normal to surface S. So for this curved surface of the cone, the direction is changing continuously, and therefore it will be difficult to calculate surface integral, right? I mean, compared to if I have to find the surface integral on this circular base of the cone. So for circular base, you can easily see that here n cap will be nothing but unit vector which is perpendicular to the surface and pointing away from the surface. So this will be nothing but minus k cap, right? Unit vector in negative z direction is the outward direction for the surface S2. So n cap will be minus k cap. So now if I calculate vector f dot n cap, this is our vector f xi. So let us discuss the second possibility where S is curved surface of the cone, right? S is curved surface of the cone. So in this case, what we will do is, instead of evaluating surface integral over curved surface, we will evaluate surface integral over the circular base of the cone, and then we'll use the concept of Gauss divergence theorem, right? So see here, if S is curved surface of the cone, then what should be the value of integral? So let me write this integral I as this is vector f dot n cap ds, right? And let me call this integral as I2, and this we are evaluating over S2, and S2 is this circular base, right? We will calculate the value of surface integral over this circular base, and we know that over the total surface, the value of surface integral is 0, right? So then from there, we will try to find what will be the surface integral over the curved surface of the cone. So here, vector f dot n cap, this will be vector f dot n cap. Vector f is xi. Vector f is xi plus yj minus 2zk. Xi plus yj minus 2zk, and n cap is minus k cap, right? So if I take dot product of these two, then I will get minus minus 2z, so that will be plus 2z. And remember, the circular base is in xy plane, right? So this means in xy plane the value of z will be 0, and therefore vector f dot n cap is 0, right? So from here also you can see that this integral I2, which was the surface integral over the circular base of the cone, this will be 0. Now see here, I is known to us. I is the surface integral over the total surface of the cone, the curved surface and the circular base. In the first part of this problem, we have discussed that using Gauss divergence theorem, this I will be 0. Now this I is nothing but I1 plus I2. I1 is the integral over curved surface of the cone, and I2 is the integral over circular base of the cone, and this will be equal to 0, right? So now using this relation that I1 plus I2, this will be 0. I2 is known to us, right? I2 is value of integral over circular base of the cone. Now if I2 is 0, then it means I1 plus I2, this will be 0, and from here also you can see that I1 will be 0, right? So the value of surface integral over the curved surface of the cone, this will be also 0, right? So for this problem, in both the cases, either it was total surface of the cone or the curved surface of the cone, the answer will be 0. But this is true only for this particular problem. In general, it will not be true, right? Because S is the total surface and S1 is only the curved surface. But here, luckily, since integral over total surface is 0 and integral over this S2 is 0, therefore integral over S1, this will be also 0, because the relation is that I will be I1 plus I2. I is integral over total surface, I1 is integral over the curved surface, and I2 is the surface integral over this circular base of the cone, right? So in both the cases, the answer will be 0. Either it was curved surface of the cone or it was total surface of the cone. Now, one similar example we had discussed in our video course, right? In our advanced example series, we had discussed this problem, that the second part of this problem, right, there instead of cone we have used the concept where there we have used a cylinder, right, but the concept will be similar. So the question, this was the problem: if vector f is this vector 4xi minus 2y squared j plus z square k. Now I will only give you the brief idea that how this problem can be solved. You can do this on your own. And S is the surface of the region bounding this cylinder and these two planes, z equals to 0 and z equals to 3. So the first part of this problem was we had to find the value of surface integral over the surface of this cylinder, right? And the second part of the same problem is that we have to find, right, we have to find the value of this quantity integration vector f dot ds. Surface S1 is the curved surface of the cylinder between these two planes, z equals to 0 and z equals to 3. For your reference, the answer is given here. For total surface, the answer will be 84 pi, and for only the curved surface, it will be 48 pi. So see, the second part of the problem says that we have to find the value of this surface integral over only this curved surface of the cylinder, right? Now, instead of evaluating surface integral over this curved surface, what you can do is you can break this into three parts. One is this top surface. Let us call this surface as S1, the top circular surface. The second is this S2, the curved surface of the cylinder. And the third one is the circular base of the cylinder. Now, using Gauss divergence theorem, you can find this volume integral of divergence of F over this volume of cylinder, right? And if that is I, right, using Gauss divergence theorem, you can find that value. And if that quantity is I, then I will be basically I1 plus I2 plus I3, where I1 is integral over this top surface, I2 is integral over this curved surface of the cylinder, and I3 is integral over this circular base of the cylinder. Now, the second part of the problem is we have to find the value of this I2, but instead of calculating I2, right, instead of calculating surface integral over the curved surface of the cylinder, it is much easier to find the value of integral over I1 and I3 because these two are flat surfaces, right? So calculate I1 and I3, and then from then using this relation, you can find the value of I2, right? So even if the problem was find the value of surface integral over curved surface of the cone, then this problem would not have been a difficult question for those of you who have solved this problem, right? So this was our first problem, right? And here in both the cases, luckily the answer will be 0, right? Either we have total surface of the cone or we have only the curved surface of the cone. Now we are going to move to our second problem. The second question was based on graph of basic function, graphical transformations. So one figure was given to us, right? The figure shows plot of this function over this interval -4 to 4, and you had to identify the correct equation. And here these points were given to us, right? This and coordinate of this point is also known. X coordinate is -4, y coordinate is -2, and similarly this point is x coordinate is +4 and y coordinate is +2, and you had to identify the correct graph. All these three options B, C and D will give us a V-shaped curve, right? And therefore the correct answer to this problem will be this option A, right? And in our video course in calculus we have discussed these graphical transformations. So if you have followed those lectures, then this was a very simple problem. Simply by looking at the question, you can identify that all these three remaining options will give us a V-shaped curve, and therefore option A has to be the correct answer, right? Now see, there are two ways of approaching this problem. One, you can use the elimination technique, meaning that suppose if I consider say this point 4, 2, right? So now let us try to identify that which option is satisfying this point, meaning that when x is equal to 4, then the value of y is 2, right? So let us try to identify, and remember these are values of y, right? All this quantity are equal to y, so you have to identify the correct option here. So see here, if x is 4, then y should be 2. Now you can eliminate a number of options from here itself. For example, this option C, when x is 2, the value of y will be, when x is 4, the value of y will be 6, right? But y should be 2, so option C is eliminated. Similarly, when x is 4, then the value of y from here you can say this will be 2 minus 4, so that will be minus 2. Again you can eliminate this option, right? Then we are left with these two options. So we have number of other points also. For example, this point minus 4 minus 2, right? Let us check for this point minus 4 and minus 2, meaning that when x is minus 4, then this will imply that the value of y should be minus 2. So when x is minus 4, from here you can see that value of y will be plus 6, and therefore this option is also eliminated. So using elimination, you will find that only option A is correct, right? So this is one technique of solving this problem. And there is another method in which we can draw the exact graph of these function, and then we can see which one is the correct. So I mean, in GATE you can use elimination technique also, but one should be familiar with entire concepts, right? Because this year they have asked simple problem, but in, I mean, you should know the concept, right? So here the first option is, if I have to draw the graph of this function, right? Option A is y equals to mod of 2 minus mod x, right? If I need to draw the graph of this function, then first we will draw the graph of this function y equals to minus of mod x, right? So if I want to draw a graph of function y equals to minus of mod x, then it will look something like this, right? This will be the graph of function y equals to minus mod x, right? This is the graph of function y equals to minus mod x. Now, if I shift this graph by 2 unit, we see this is the graph. This is minus mod x plus 2, right? So if I have to add 2 in this function, then it means we have to shift this graph by 2 unit towards positive y-axis. So this point 0, 0 will move somewhere here. This point is say x coordinate 0, y coordinate plus 2. So we will get a graph something like this, right? This is the graph of function y equals to this will be the graph of function y equals to mod of 2 minus mod x, right? This is the graph of function y equals to mod of 2 minus mod x. Now, sorry, this is not mod of 2 minus mod x. This will be graph of 2 minus mod x, right? Because this is minus mod x, and we have to shift that graph by 2 units towards positive y-axis. Now in the next step, if I have to take the modulus of this entire thing, then we have to delete the portion of graph which is below this x-axis and take its image in x-axis, right? So if I erase this portion and take its image, then I will get a graph something like this, right? And similarly here also you will get this branch. So now this will become graph of function mod of 2 minus mod x, right? So this was the graph which was given to us. The graph will be, you will get a W-shaped curve something like this, right? This will be our graph of function y equals to mod of 2 minus mod x, and you can very easily see that this point will become 2 0. When x is 2, the value of y will be 0. This point will be minus 2 0, and you will get these 2 points also, right? So option A itself will satisfy the criteria which is given, right? The graph which is given to us. Now option B, 2 minus mod x, this we all know is a V-shaped curve, right? This graph y equals to 2 mod of 2 minus x, or you can write mod of x minus 2. This will mean the same thing. So here if I want to draw the graph of this function, then you will get a V-shaped curve, and this will be the vertex of that V-shaped curve. When x is 2, you can see that value of y will be 0, and you will get a curve something like this, right? So this is our graph of function y equals to 2 minus mod x. Then the next one is y equals to mod of mod x plus 2. Now see here, this option, here it is given that we have option C is y equals to mod of mod x plus 2. Now see here, this second mod is useless because the quantity inside this mod is positive, right? Mod x plus 2, this will be a positive quantity, and therefore you can remove this modulus sign and you can simply write mod x plus 2, right? So for option C, the graph will be, we have to draw the graph of function mod x plus 2. So first draw the graph of function y equals to mod x, and then it shift this graph by 2 unit towards positive y-axis. So this will be the graph of function y equals to mod x plus 2, right? And option D, I think we have already covered. Option D is 2 minus mod x, right? So this is, I mean, one step before this option A, right? 2 minus mod x. This was the graph of function. This graph was the graph of function 2 minus mod x, right? So from here also you can see that only option A will give us a W-shaped curve. All these three options B, C, and D will give us a V-shaped curve, right? And therefore the correct answer to this problem will be this option A. So these were the two problems. Now let us move to the next question. This was an interesting problem. The question was based on the concept of Cauchy-Euler homogeneous differential equation, right? And here the important thing that you should notice is the second derivative d2y by dx square is multiplied by x square. dy by dx, this is multiplied by x, right? So this is basically Cauchy-Euler homogeneous differential equation, right? Or you can say Euler-Cauchy differential equation, right? So this was the differential equation. Now in this differential equation, there is one standard substitution that I'm sure you must have learned. The substitution here is that in place of x, you have to write e to the power t, right? If x is e to the power t, in place of x we can see this is a differential equation with variable coefficient, right? But if we know how to solve a differential equation with constant coefficient, right? If we have constant coefficient, then we calculate complementary function and particular integral, and then complete solution is sum of those two, right? Sum of complementary function plus particular integral. Now here if I can convert this differential equation with variable coefficient into a differential equation with constant coefficient, then we can easily solve that. And for that, the standard substitution is x equals to e to the power t. Now, the moment you do this substitution, then in place of x dy by dx, you can write capital dy, where this symbol capital D is representing derivative with respect to t, right? And similarly, in place of x square d2y by dx square, you can write d minus 1 y, right? So, and again d is capital D is d upon dt. So once you do this substitution, then you can write this differential equation as, right? This was the given differential equation. So you can write that differential equation as, in place of x square d2y by dx square, you can write d minus 1 y, right? So let me do that. We can rewrite the differential equation as d minus 1 y, right? In place of x square d2y by dx square, we can write d minus 1 y, and in place of x dy by dx, we can write capital dy minus y equals to 0, right? Now you can, this is our new differential equation, right? Differential equation with constant coefficients. So now what you can do is you can rewrite this as d square minus d plus d minus 1. This we have to operate on y. This will be equal to 0. These two will cancel. D square minus 1. This is 0. Now you can directly see the roots of auxiliary equation here. The auxiliary equation will be m square minus 1 equals to 0. And therefore the roots of auxiliary equation are minus 1 and plus 1. Right? And therefore the complementary function, which is also the complete solution because the particular integral will be 0. So the complementary function will be c1 e to the power x plus not x, because here the independent variable is t. So c1 e to the power t plus c2 e to the power minus t, right? This will be the complementary function and also the complete solution. Now e to the power t is nothing but x. So this will be c1x plus c2 by x. So this is the general solution of the differential equation, right? This will be the general solution. Now two conditions are given to us. One condition is y of 1, this is equal to 6. So from here you can write that c1 plus c2, this will be equal to 6, right? This is our first equation. And similarly y dash 1, this is equal to 2. So this will mean that if I differentiate this, then I will get c1 minus c2 by x square, and in place of x, if I substitute 1, then I will get c1 minus c2 equals to 2. Now we have to solve these two equations. So from here you can see that C1 will be 4 and C2 will be 2. Right? Now once C1 and C2 are known to us, we can write the particular solution of this differential equation. This was our general solution. Now substitute the value of C1 and C2. So the particular solution will be C1 is 4. So 4x plus 2 by x. Now this is the particular solution of the differential equation, which will satisfy the differential equation as well as the two boundary condition. So now we have to calculate the value of y of 2, right? When x is 2, then what should be value of y? So this will be nothing but 4 into 2 plus 2 by 2, right? So 4 into 2 will be 8, 8 plus 1, this will be 9. So y of 2, this will be nothing but 9, right? So the correct answer for this problem will be 9. The answer to this problem is, now we are not aware whether this was options were given in this problem or it was MSQ, I mean numerical answer type question, but the correct answer for this problem will be 9, right? So this was third problem, and again this was a doable question because similar question we have discussed in our course also, right? Problem based on Euler-Cauchy homogeneous linear differential equation. The key here is that you should be able to identify that the second derivative is multiplied by x square, first derivative is multiplied by x. This means we have to do the substitution x equals to e to the power t, and once you do that substitution, then a differential equation with variable coefficient is reduced to a differential equation with constant coefficient, right? And it is very easy to solve a differential equation with constant coefficient. Also, in place of x dy by dx, you have to write capital dy, and this will be d minus 1 y, right? So we obtained this differential equation with constant coefficient. Now this was the general solution. From this general solution, we have calculated the value of these two arbitrary constants C1 and C2, right? Y1 was 6, Y dash 1 was 2. Find C1 and C2. Then this is particular solution, and the value of Y2 will be 9, right? So this was our third problem. Now till now we have discussed these three questions, and all of them were doable problems. This was a very basic problem. If it was total surface of the cone, even if it was curved surface of the cone, then you can use the concept that we have discussed, right? Then next problem was this graphical question based on graphical transformation, and this is our third problem based on Euler-Cauchy homogeneous differential equation. The next problem is x cap is 3y and y cap is 2x. Then we have to find the area of this disk x square plus y square less than equal to 1. Now this was a slightly different problem, but not a difficult problem. Right here in this problem, what we have to do is this circular disk is given to us x square plus y square less than equal to 1. Now, if I do this transformation, that in place of x cap I write 3y and in place of y cap I write 2x, then I will get a different sort of different curve. So basically, we have to find area of that particular curve. So let me explain that with the help of this figure. See here this equation x square plus y square less than equal to 1. This will represent a circle. All the points which are either on the circle or inside the circle. The radius of the circle will be 1 unit and the center is at origin, right? If it was greater than 1, then it will represent a point outside the circle. If it is equal to 1, then it will represent point on the circle. And if it is less than 1, then it will represent all the points which are inside the circle. So basically, this inequality is representing these set of points, right? These collection of points, all the points which are either on the circle or which are inside the circle, right? So this inequality x square plus y square less than equal to 1, this inequality will represent all those points which are either on the circle or inside the circle, right? So it will cover all those points. Now the transformation is that x cap is 3y, right? And y cap is 2x. Meaning that if I take any point xy, let us consider that if I take this point 1 is 0, right? In this circular design, if I take point 1 0, then what will be the corresponding point x cap and y cap? So this x cap will be 3 into 0, which is 0. And y cap, this will be 2 into 1, so that will be 2. So this simply means that point 1 is 0 in xy plane will move to this point 0 comma 2 in x cap y cap plane, right? So similarly each point will move to some other point. So the question is what will be the locus of all that point, and then we have to find the area of that region which is formed by the by those collection of points. So see here all we have to do is, if x cap is 3y, right? If x cap is 3y, then it means that y will be x cap by 3, and similarly x will be y cap by 2, right? This will be the relation between x and y and x cap and y cap. So now the inequality was x square plus y square is less than equal to 1. Now in this inequality, if I substitute these two expression, in place of y I will place x cap by 3 and in place of x I will place y cap by 2. So I will get y cap square by 2 square plus x cap square by 3 square less than equal to 1. Now let us rearrange this. So I will get x cap square by 3 square plus y cap square by 2 square, and this is less than equal to 1. So this is the new locus of point that we will get, right? If all the points which were inside this circle or on this circle are will move under this transformation, then we'll get a curve which will follow this inequality, right? X cap square by 3 square plus y cap square by 2 square is less than equal to 1. Now if you can notice here, this is nothing but collection of all those points which are either inside the ellipse or on the ellipse. We know that if we have this equation x square, if we had equality here, right, x square by 3 square plus y cap square by 2 square equals to 1, then it will represent all the points which are on the ellipse. So here, since we have less than or equal to 1, so it will represent collection of points which are either on the ellipse or inside the ellipse, right? So this inequality will basically represent all these points. Now the question is, what will be the area of this region, right? So the problem was not to find the area of that circular disk. The problem was once those transformations are done, then each point, for example, now you can notice what is happening. This point 1 is 0, the point 1 is 0 on this circle, right? This was the point 1 0 on the circle. Now under this transformation it will move to point 0 2. So meaning 0.02 point will be somewhere here, right? X coordinate will be 0, y coordinate will be 2. For this ellipse you can see that this is the vertex of the ellipse 3 0 and minus 3 0, and similarly these are the endpoints of minor axis, right? 0 2 and 0 minus 2. So you can see that all those points on circle, right? If I take any point on this circle and if I do the transformation, this transformation, x cap is 3y, y cap is 2x, then I will get another point which will lie inside this ellipse, right? So collection of all those points will give us this locus. Now the question is, what will be the area of this ellipse? So we all know that the standard formula, if the ellipse is x square by a square plus y square by b square equals to 1, right? If this is the ellipse, then the area of this ellipse is nothing but pi a b, right? Where a and b are the length of semi-major and semi-minor axis. This is the standard formula to find area of ellipse. And remember, when a is equal to b, then this ellipse will reduce to a circle and area will become pi r square, right? Or pi a square, where a is the radius of that circle. So now here, this is the ellipse that we have, and the area of this ellipse will be nothing but pi. A is 3 and b is 2. So the area of this ellipse will be nothing but 6 pi, right? So this will be the answer to this problem. The area of this ellipse will be 6 pi. And I'm sure many of you have solved this problem, but you should know the concept also, that why, I mean, what is the meaning of this area 6 pi, right? So here the meaning basically is that this inequality will represent a circle, right? Collection of all those points which are either on the circle or inside the circle. Now if I take image of any point on this circle under this transformation, x cap is 3y and y cap is 2x, so I will get another point on the ellipse, and if I take any point inside this circle, then I will get a corresponding point inside the ellipse. So we have to find the area of this elliptical disk that we are getting here, right? So the area of this elliptical disk will be 6 pi, and therefore the correct answer to this problem is 6 pi. Now you can substitute the value of pi and you will get 16 point something as your answer, right? So this was our fourth problem. Now the next question is, this was again a very interesting problem, and a similar question was asked in GATE 2021 also. And again, this was not a difficult problem because similar problem was asked earlier also in GATE 2021 mechanical. They have asked similar problem. This question is based on stability of Euler's method, and this problem becomes even easier because the condition for stability is already given to us. right? Yn plus 1 is less than equal to yn. So this condition is given to us, and therefore we have to, and therefore this problem becomes a little easier, right? So the question is, we have to solve this initial value problem, dy by dt plus 2y equals to 0, y of 0 is 1, right? And this is to be solved using forward Euler's method. Now forward Euler's method is same as Euler's method with constant time step of delta t. Delta t is positive, I mean that is obvious. So the question is the condition this is satisfied if delta t does not exceed. So see, in this problem we have to find the range of delta t for which the solution remains stable, and if the range of delta t is from say k1 to k2, then the maximum value of delta 2 will be k2. So this k2 is something that we have to calculate, right? So first let us write that given differential equation. The differential equation is dy by dt equals to minus 2y, right? Dy by dt plus 2y is equal to 0. So dy by, and this condition is not important here. So dy by dt plus 2y is equal to 0. Therefore dy by dt equals to minus 2y, and this is nothing but f of ty, right? This is the given differential equation. Now we know that in case of Euler's forward method, the formula is, in case of Euler's forward method, the formula is yn plus 1. This is nothing but yn is the solution at any point. So if solution at any point is known to us, then we can calculate the solution at next point using this formula. So yn plus 1, this is equal to yn plus delta t into, and here we have to write this quantity, meaning we have to write f of tn and yn, right? This is something that we have to write here. So now this will become yn plus 1, and this will be equal to yn plus delta t, and see the expression for f of ty is minus 2y. So similarly here also you will get minus 2 times yn, right? So now we can rewrite this relation as yn plus 1. If I take yn common, then I will get 1 minus 2 times delta t, this multiplied by yn, and this is the relation that we have obtained. Yn plus 1 is 1 minus 2 times delta t multiplied by yn, right? Now see, in the problem itself it is given that this is the criteria for stability. Let me write the criteria here so that you can easily find the inequality here. So here it is given that y mod of yn plus 1, right? Let us see this again. Yn plus 1, this is less than equal to mod of yn. So now this is the relation that we have. Now in this relation, what should be the criteria on this constant quantity so that yn plus 1 will be less than or equal to yn? So it is obvious that yn plus 1, right, is some this is some expression multiplied by yn, right? Yn plus 1 is this expression multiplied by yn. So it is obvious that if 1 minus 2 times delta t, this is less than or equal to 1, right? Then obviously yn plus 1, this will be less than yn, right? And this will be the criteria for stability here. Now just solve this inequality. We all know how to solve this modulus, this type of inequality, mod x less than a. So this means here this quantity 1 minus 2 times delta t, this will be between minus 1 to plus 1, right? So 1 minus 2 times delta t, this is between minus 1 to plus 1. So from here you will get minus 2 times delta t, this will be between minus 2 to 0, right? And if I divide by minus 2, then I will get delta t between 0 and 2, right? When we divide by negative number, then we have to change the sign of inequality. So basically delta t belongs to this interval 0 to 1, right? So the condition for stability will be the minimum value of delta t will be 0 and the maximum value of delta t is 1, right? So this was the problem. We had to find the maximum value of delta t for which the system is stable. So the correct answer will be delta t max, this will be 1, right? So the answer for this problem is 1. And again, this was slightly different problem, but this type of question has been asked earlier also. And the interesting part is that here, even if you don't know the criteria for stability, simply write the relation and then you have to satisfy this inequality. Yn plus 1 is less than equal to yn, right? So once you have written this relation, right? Once you have obtained this relation yn plus 1 is this expression multiplied by yn, then from here you can easily identify that if this quantity is less than 1, then the system will be stable, then that condition will be satisfied, right? So, and just solve this inequality, the range of delta t is from 0 to 1, and therefore the maximum value is 1, right? You can see that here it is given that this is satisfied if delta t does not exceed. So if delta t is between 0 and 1, then this inequality will be satisfied. So the maximum value of delta t, this will be plus 1, right? So this was our fifth problem. Now the next question is, this was an interesting problem. We had to find the inverse transform of this function. Now in last 2-3 years, there was one question based on inverse transform, and the remaining problem were either from Fourier transform or to find Laplace transform. Now in this question, there is one confusion regarding different options which were given to us, right? So first let us solve this problem, and then we will see what are different ways in which you can write the same answer, right? So see here, f of s is given in this manner. If I take s common in denominator, then f of s is nothing but s into s minus 1 s plus 1. This is our f of s. And if I want to write, see here you have 1 upon 3 linear factors. So if I want to use the concept of partial fraction, then I can write this as a upon first linear plus b upon second linear plus c upon third linear, right? And now we have to find the value of ABC here. So see, for calculating ABC, what you can do is, if I take LCM here, right, LCM will be S into S minus 1, S plus 1, right? If I take LCM, then I will get A into S minus 1 into S plus 1, right, plus B into, I mean, this is the easiest way to write partial fraction. In this method, you don't have to remember anything, right? Plus C, here you will get B into S plus 1 and C into S into S minus 1, right? This is something that you will get. Now see, these two expressions are equal. This is our f of s, and here also we have f of s. Now if these two are equal, then it means that the numerator of these two will be equal because the denominator is equal. So you can write from here that a into s minus 1 s plus 1 plus b into s plus 1. Now again, there are other ways of writing partial fraction, but this is the most convenient method. So now this is the relation that we have obtained, right? This is the relation that we have. Now in this equation, either you can substitute different value of s, or since these two quantities are equal for all the values of s, therefore coefficient of similar power of s will be equal on both sides. So either you can equate the coefficient or you can substitute different value of s here. So if you substitute different value of s, for example, if I place s equals to 0, these two will become 0 and you will get a into minus 1 equals to 1. And from here the value of a will be 1, right? So from here you will get value of a as 1. Similarly, if I substitute s equals to 1, right, then these two will become 0, the first and the third term, and you will get b into 1 into 1, 2, and this will be equal to 1. So the value of b, this will be 1 by 2. And similarly, if I substitute s equals to minus 1, then you will get c into minus 1 minus 2. Minus 1 minus 2, that will be plus 2, and this is equal to 1. So from here, the value of c will be 1 by 2, right? So the value of a, let me do correction here. A into minus 1 is 1. So the value of a, this will be minus 1. B will be 1 by 2 and C will be 1 by 2. So now you can write your f of s as f of s, this will be minus 1 upon s plus 1 upon 2 into s minus 1 plus 1 upon 2 into s plus 2, right? This is something that you will get. Now here f of t, which is inverse transform of f of s, right? Inverse transform of f of s. This will be nothing but inverse transform of minus 1 by s. This will be minus 1 plus 1 upon 2 into e to the power t, and from here you will get e to the power minus t, right? So this is one possible answer, right? F of t equals to minus 1. Again, that will depend on what are options which are given. So this is one possibility. You can write f of t as minus 1 plus 1 by 2 into e to the power t plus e to the power minus 2. Now another possibility is that, see, you can write the same function. We know that unit step function u of t is given in this manner. Ut is 1 when t is positive and it is 0 when t is negative, right? So this is how a unit step function is defined. So you can write the same solution in this manner also. You can write f of t equals to minus 1 plus e to the power t plus e to the power minus t, this divided by 2, right? And this quantity multiplied by unit step function, because the value of unit step function is 1 when t is positive, right? So this is another way of writing the same answer. You can write the answer by multiplying this with unit step function. The third possibility is that you can use the definition of hyperbolic cosine, meaning in place of e to the power t, right? We all know that e to the power t plus e to the power minus t by 2, this will be nothing but hyperbolic cosine t, right? So you can write the same answer in this manner also. You can write f of t as hyperbolic cosine t minus 1, right? And again you can write in this manner, or you can multiply this by unit step function. So these are the different possibility. Now since these are memory based question, so I mean it is not always clear what are the options which were given in the problem. So whatever be the option, the key concept here is that since we have 1 upon product of three linear, so first write the partial fraction, and once the partial fraction is written, then this is our f of s, right? So from here calculate inverse transform, this will be the inverse transform. Now you can write the same answer by multiplying with unit step function, or you can use the concept of hyperbolic cosine function. In place of this quantity e to the power t plus e to the power minus t by 2, write hyperbolic cosine, and then you will get the you can get any one of these three answers. Again, that will depend on the options. So this was our sixth problem. Now the next problem is from complex analysis, right? This question was based on Cauchy-Riemann equation. Here it is given that f is this function e to the power minus kx multiplied by cosine 2y minus iota into sine 2y. And it is given that this is an analytic function, so we have to find the value of k. Now the moment you see this word analytic function, right, a function is analytic function, then it will always satisfy CR equations, right? So here using CR equations, we had to find the value of this constant k. Because the function is analytic, it will satisfy the CR equation. Now see, if you see the last 2-3 years paper, you will find that there are two kinds of problem which are frequently asked from this chapter, complex analysis. Either question based on residue theorem is asked, or problems based on CR equation is asked, right? So for example, last year they have asked problem based on residue theorem, but this year they have asked question based on CR equations, right? So we know that if a function f, which is u plus iota v, where u and v are function of x and y, right? Both u and v are function of x and y. So if this function is analytic, then it will satisfy CR equation, and therefore CR equation is nothing but partial derivative of u with respect to x. This will be equal to partial derivative of v with respect to y, right? And similarly, partial derivative of real part of the complex function, that is u, with respect to y, this will be negative of partial derivative of v with respect to x, right? So these two equations combined are called Cauchy-Riemann equation, and whenever a function is analytic, then it will satisfy both of these equations. But here for finding value of k, only one equation is sufficient. So here, see, here it is given that f is e to the power minus kx into cosine 2y, right? E to the power minus kx multiplied by cosine 2y plus iota times e to the power minus, sorry, there is a minus sign in between, so you will get minus e to the power minus kx into sine 2y, right? So this is the complex function that we have. E to the power minus kx multiplied by cosine 2y, this will be the real part of the complex function, and e to the power minus kx multiplied by minus sine 2y, that will be the imaginary part of the complex function, right? So this is the real part of the complex function, and this one is the imaginary part. So now using CR equations, we have to find the value of this constant k. So since f is analytic, it will satisfy CR equation. Now here, if I use the first equation, let me call this as first CR equation, and this one is second. So if I use the first equation, then partial derivative of u with respect to x, this will be equal to partial derivative of v with respect to y. Remember, the first function is u, this one is u, and this is our v, right? U is the real part of the complex function and V is imaginary part. So if I differentiate U with respect to X, then this means I can take cos 2y outside because it will be constant, e to the power minus kx multiplied by minus k, and this will be equal to, if I differentiate imaginary part with respect to y, then I will get minus e to the power minus kx multiplied by 2 into cosine 2y, right? So now cosine 2y, these two will cancel, e to the power minus kx will cancel, so basically minus k, this will be equal to minus 2, and from here the value of k, this will be 2, right? So if k is equal to 2, then the function will be analytic. So the, I mean, from here itself we have obtained the correct answer, but if you want, you can verify the second equation also, right? Because if any one option is that there is no value of k for which this is analytic, then you have to check both the option. But if this is numerical type question, numerical answer type, then from here itself you can say that the value of k will be 2, right? So let us see what will be the second equation. Del u by del y, this is minus del p by del x, right? So now if I calculate del u by del y, let me write u and v again. So now that k is known to us, we can write u and v in terms of some constant and not k, right? So u is e to the power minus 2x into cos 2y, right? U is e to the power minus kx into cos 2y, and similarly v is minus e to the power minus, sorry, in place of k we had to write 2, so let me erase this part here. We are substituting the value of k. K is already known to us, right? K is equal to 2. So e to the power minus kx into cosine 2y, and v is e to the power minus 2x into sine 2y. Now let us check whether second equation is satisfied or not, because sometimes in GATE they have asked such problem that there is no value of k for which the function is analytic. Because if the function is analytic, then it has to satisfy both of those equations, right? So now partial derivative of u with respect to y, this will be minus e to the power minus 2x into 2 into sine 2y, right? And partial derivative of v with respect to x, this will be minus e to the power minus 2x, and here we have to multiply this by the coefficient of x, so this will be minus 2 and multiplied by sine 2y, right? So as you can see that these two are negative of one another, and therefore the second equation is also satisfied. Del u by del y is in fact equal to minus del v by del x, right? So if it was numerical answer type question, then from the first equation itself, from here itself, you can say that the correct answer will be k equals to 2. But if it is objective problem, four options are given to us, and one of the options is that there is no value of k for which the function is analytic. So in that case, you have to check the second equation also. Now here, since the second equation is also satisfied for this particular value of k, therefore k equals to 2 is the answer, right? When k is 2, then the function will be analytic. So for this problem, the correct answer will be 2. And again, these are memory based questions. So we are not sure what are the options which were given in the problem. So these are the two possibility, right? If it is numerical answer type, then directly from the first equation itself, the answer is 2. If it is four options are given and one of the option is there is no value of k for which it is analytic, then you have to check both the options, because a function is, if a function is analytic, then it will satisfy this equation as well as this second equation, right? So this was our problem number 7. Now the next question is, this problem was very easy. The problem was based on Poisson distribution, right? Mean and variance of Poisson distribution. And such problems have been asked in GATE earlier also. So this was not a difficult problem at all. The question is the probability of defective pieces made from a machine is 0.015. Right. So as you can see that in case of Poisson distribution, probability of success is very low. Here the success is getting a defective piece. So probability of success is 0.015. Right. If it follows Poisson distribution, then find mean and variance for, not from, for 200 products made, right? So this is the problem. For 200 products, we have to find mean and variance. Now we know that in case of Poisson distribution, mean lambda is nothing but n into p, and variance sigma square is also equal to n into p, where n is number of trial and p is probability of success in each trial. Now here we are talking about 200 products, so therefore n will be 200, right? and P is probability of getting a defective piece, and its probability is 0.015, right? So the value of lambda, this will be nothing but n into P. N is 200, P is 0.015. So this number will be 3, right? Now lambda is 3. Therefore, in for Poisson distribution, since mean and variance are same, so this mean will be equal to variance and this will be equal to 3, right? So the correct answer for this problem is both the mean and variance are 3. Also, if the question was find a standard deviation, so standard deviation sigma is nothing but square root of variance, right? So if variance is 3, then a standard deviation will be root 3, right? So this was a directly formula based problem, and the correct answer for this problem will be mean lambda is 3 and variance sigma square is also 3, right? So this will be the answer for this problem. And the last problem from mathematics, I mean, this problem can easily qualify as a problem of aptitude, right? So at this point, we are not sure whether this was asking aptitude section or in mathematics, but let us discuss this question. The problem is area of a rectangle is 4 square units. So the question is we have to find minimum possible perimeter, right? Now, suppose the two sides of the rectangle are A and B, then it is given that AB is 4. And what is perimeter? Perimeter is 2 times A plus B. So we have to find a minimum value of twice of A plus B, right? So if we use the concept of arithmetic and geometric mean, then we know that if I have two positive numbers, then their arithmetic mean is always greater than equal to their geometric mean. So this will mean that A plus B by 2, this will be greater than equal to 4, which will imply that A plus B, this will be greater than equal to 4, right? Now perimeter is twice of A plus B. So the minimum value of perimeter, this will be equal to twice and 2 times 4, which is nothing but 8, right? So the correct answer for this problem will be the minimum possible perimeter is 8. Also, remember that when area is constant, then the perimeter will be minimum when it is a square, right? When rectangle reduces to a square, then only its perimeter will be minimum. Or for a given perimeter, the area will be maximum when it is a square, right? So, I mean, if you know that concept, then the problem is very simple and the correct answer will be 8. So we have discussed all the 9 problems, and if you see these questions, then you will realize that this year mathematics paper was not difficult, right? It was somewhere between easy and moderate, because there were some good questions, right? For example, this was a good problem if the surface was curved surface of the cone, and then this graph of function, this was again you can substitute the point and get the correct answer. The next problem was Euler-Cauchy homogeneous differential equation. So this was also consistent with previous year paper, right? I mean, this question is not difficult at all. Then the next, this was slightly different problem, right? In this question, first we had to find what will be the curve which we will get after this transformation, and then we have to find the area of that curve, right? So, and then this was again a problem which was asked in GATE 2021 also in mechanical. And here the problem becomes easy because the condition for stability is already given to us, right? It is already given that yn plus 1, modulus of yn plus 1, this would be less than equal to modulus of yn. Then the next question was from inverse transform, Laplace transform. This is again a simple problem. This was analytic function, problem based on CR equation, and the last two problems were, one was from Poisson distribution, easy problem, directly formula based, and this was an aptitude question, right? So total 9 problems were there, and except for maybe for this one problem, right? You can say that all the other problems were very easy, right? Not even difficult problems. And this was also formula based and the condition is given to us, right? So I hope that your exam went well and I wish you all the best.